So for number 2, what you have here is that you're gonna have to separate all the ions. So you have your balanced equation right here, okay? And what you're gonna do, first and foremost, is you're going to separate all the ions. So how do we know which ones are all the ions? Well, I'll make it very simple for you. Anything that is an AQ, you're going to separate into their ionic form. So that means you're going to separate this one, you're going to separate this one, and you're going to separate this product. So you'll separate this whole reactant, you're going to separate this whole reactant, and you're going to separate this whole product. You cannot separate this one because it's no longer living in the ionic form in solution anymore. It came out of solution. So then what you're gonna have here is, well, you're gonna go through here, and if you remember from the previous video or the previous example, okay, we already have the charges, okay? So that means I'm gonna draw them up here again, and this is +2, and this is gonna be +1, and this is gonna be -1 and -2, okay. So then for the first one, you're gonna separate Ba and NO3. So the first thing you have to realize, is there a subscript? And there is not. And is there a coefficient? And there is not. So what you're gonna do is you're gonna multiply a subscript times the coefficient, and that's gonna be your coefficient in front. So because it's 1 and 1, you're just gonna end up with Ba, and we're gonna put +2. And we have to denote that it's in solution. And then we go to the next ion, which is gonna be NO3. If you notice, the coefficient for NO3 is gonna be 1, but there's a subscript of 2. So that 2, you're gonna multiply it 2 times that 1, and it's gonna end up being 2. And then you have NO3, so you have 2 of those NO3 ions with a -1 charge, and it's in solution, so it's AQ. Then you go to the next reactant, which is K2CO3. Same thing, you're gonna multiply subscript times the coefficient, which is 2K, and in this case it's gonna be +1, and it's in solution, so we'll write AQ, plus, this one doesn't have parentheses, so it has 1 as a subscript, times the 1 coefficient, it's just gonna be CO3, -2, AQ, and then of course you have your precipitate here. That one is no longer an ion or in solution, so you're gonna keep it together. And then the next thing, you're gonna separate the last product. So if you notice here, you have K, 1 subscript times 2 as a coefficient, you're gonna have 2K, and it's +1. And then it's AQ, and then plus NO3, and since there's a coefficient in front, you have to put a 2, because it's 2 times the 1 of the subscript, and then this one's going to be a -1. It'll be AQ. Okay. Right, so that's for the complete ionic equation. That is answer for number 2. The next thing you want to do is you want to identify your spectator ions. So what does a spectator do? It just watches, but it does not partake. For example, fans at a basketball game or NFL game, they don't partake into the sport, they're just observing and watching. Same thing with these spectator ions. They don't partake into the reaction, they're just observing. So that means that they're gonna be on both sides of the arrow. So how do I identify spectator ions? These are gonna be the ions that kind of redundant, but ions that are in the ionic form, or species I should say, species that are in the ionic form on both sides of the arrow. So in this case, you'll notice that you have K and K are ions on both sides of the arrow, because the arrow is right here. So K would be one spectator ion. So one of the spectator ions is going to be K plus 1, right? And so you're going to cancel it out. And then the next one is going to be NO3. And so because that's the other one, so you're going to write it down, NO3 negative 1. So that's the other spectator ion. And so once you've gotten rid of your spectator ions, and we've identified them, right? So that's answer for number 2, answer for number 3. Lastly, all you have to do is write the net ionic equation. The net ionic equation is going to tell you the ions that are the ones responsible for the reaction happening, or in this case, the precipitate. So that means if you notice, we're just going to write the 2 ions that are left over plus the precipitate. And that's going to be your net ionic equation. Ba plus 2, I'll show you in black, plus CO3 negative 2 yields barium carbonate. And that is your net ionic equation.